Hello children, welcome to yet another session of science. This is our usual meeting point, hoping you are ready to learn. Thank you. Yes, our dear children, boys and girls, this is yet another time for us to learn something in science. And if you can recall, from the beginning of this program, we've been talking about light. So in the previous lesson, we looked at lenses. I don't know whether you can remember. We talked about lenses. What did we say a lens is? If somebody is able to remind me. Yes, so we said a lens is simply a transparent material that is capable of refracting light that passes through it. I repeat, a lens is a transparent material that is capable of refracting light that passes through it. Are we there? Hoping you're following, you are not so well. We also discussed about different types of lenses. Which ones did we talk about? Yes, my dear, if you can recall. Yes, one, we talked about convex lenses, or sometimes we call them converging lenses. We also talked about concave lenses, or we can call them diverging lenses. Now today, we are going to talk about another type of lens, and that is a diverging lens. We're going to talk about a diverging lens, which is a concave lens. Are we there, children? We're going to talk about a concave lens. Now, we want to look at some of the characteristics of concave lenses. When a collimated beam of light passes through a concave lens or a diverging lens, what happens? When I talk of a collimated beam, I am talking about a parallel beam of light. Are we there? So we want to look at first of all the characteristics. How do these concave lenses look like? There we are. We are saying a concave lens is thinner at the center and thicker at the edges. When we compare it to a convex lens, you'll find that a convex lens is thicker at the center and thinner at the edges. But here we're talking about a concave lens. A concave lens is thinner at the center and thicker at the edges. Number two, we are saying a concave lens is also called a diverging lens. I want you to look at the word diverging. To diverge simply means to spread out. That's why a concave lens is called a diverging lens, because it spreads out light. If a collimated beam of light falls on a concave lens, it spreads out. If a parallel beam of light falls on a concave lens or passes through a concave lens, it spreads out. Children, have you ever seen a concave lens? Some may have seen, some may have not seen. But we want to look at another characteristic. We are saying a concave lens is curved inwards. A concave lens is curved inwards. Now, comparing it with a convex lens is curved outwards. I repeat, a convex lens is curved outwards, but a concave lens is curved inwards. Are we there? So, we want to look at what we call a concave lens. There, you can see a diagram of a concave lens. When you look at the diagram, you find that it is curved inwards. At the sides, it is curved inwards, compared to a convex lens which is curved outwards. Now we also said that a concave lens is thinner at the center. It is thinner at the center. What makes it thinner? The curves, which curve inwards compared to a convex lens, which is curved outwards. So, we want to look at the effect of a concave lens on a parallel beam of light. We want to look at the effect of a concave lens on a parallel beam of light. Let's see what happens. So according to our statement, we are saying that a concave lens diverges light. Keynote. I'm pointing there, the word diverges. A concave lens diverges light after passing through it. Like I said, if a collimated beam of light passes through a concave lens, it diverges. When I talk of collimated, a parallel beam of light. Now, let's look at this diagram and see what happens. You will realize that these rays of light are hitting a concave lens. When you look at them, all of them, but at the front, after passing through a concave lens, all of them diverge. They spread out. We also want to look at the characteristics of images formed by a concave lens. Are you together? You learned about images. An image is simply a light picture. Are you together? An image is simply a light picture. So what are some of these characteristics? Remember, images are formed as a result of light falling on an object. For example, if light falls on your eye, you are able to see an image. An image is formed. Now, what are these characteristics? Number one, we're saying the image is upright. What does it mean to be upright? When you look at the positioning of yourself when you're seated on a chair, if your image is focused on a concave lens, it will not be reflected. It will not be shown. It will not show that you'll be lying. Are you together? It will not show you lying down, but it will show you seated in the position you are. Are you together? So your image will always be upright. The positioning of the image or the positioning of the object will not be different from that one of an image. Want to look at another one? We are saying the image is virtual. Are you together? Let's look at the word virtual. If you have a dictionary around, we are saying virtual images are those images which cannot be cast on the screen. Like for example, let me take you back to plane mirrors. If you go and dress up in front of the plane mirror, are we there? To check whether you've put on your tie well, to check whether you've tucked in very well, to check whether your eyes are looking so good, you'll find that when you move away from the plane mirror, the image also moves away from the plane mirror. The image does not remain on the plane mirror. So when we talk about virtual images, children, we're saying these are images which cannot be cast on the screen. Are we there? Are we learning? Yes. Let's look at number 3. We are saying that the image is diminished. Our keyword here is diminished. Children, do we have dictionaries there? When we talk about the image being diminished, it means the image formed by a concave lens is smaller than the object. Are we together? Do you have a concave lens around? If you look at a tree, the image of the tree that will be formed in a concave lens will be smaller than that of a tree. Are we together? So that is the meaning of the word diminished. The image being smaller. So these concave lenses produce smaller images. Now, in life, we have a number of instruments, or we can call them optical instruments, which use concave lenses. Do you have any around? Try to look around. Maybe on your door, somewhere there in the house. Maybe at the corner, somewhere there. Because we have talked about these concave lenses producing diminished images. Do you have any around? Yes, you may be having. Let's look at one. And one example here is the lasers. Have you ever heard of lasers? Are we there? Lasers are simply used to produce very bright light of a greater wavelength. Are we there? In some factories, in some places, you'll find that people use lasers for various reasons. So they are used to produce light of a greater wavelength, of a greater intensity. We also have what they call flashlights or floodlights. For us who love watching football, look at the stadiums around. You'll find that at night, games may be played. But what helps us to play the games? What provides light? We have the flashlights or floodlights, which produce a lot of light that enables us to see. We also have our reading glasses. Sometimes we call them spectacles. Look around you. You have a brother, maybe having a sister, your father, your mother, maybe wearing spectacles. But wearing spectacles is not for fun. Are we there? It is not for beauty. Are we there? But spectacles are basically worn for some reasons. And that's why you find that some of your parents, some of your brothers are not able to read without reading glasses. Because those glasses have got concave lenses or convex lenses. But this time we're talking about concave lenses. We shall talk about later. In details, we shall talk about reading glasses or spectacles that use concave lenses later. We also have what they call peepholes. In your houses, your fathers, your mothers had to buy wonderful door shutters. And in those wonderful door shutters, you find that they have installed what we call a peephole. In that peephole, we have a device that uses a concave lens. It is able to make you view from inside the house. You're able to view what happens outside your house, outside the door, widely, because of the presence of a concave lens. Are we there? Yes, children. I want you to look at these instruments in detail. Get a dictionary, a science dictionary. Go to your computers, Google, and get where these concave lenses are applied. To sum it all, we want to look at the uses of concave lenses. Are we there? We want to look at the uses of concave lenses. One, concave lenses are used in spectacles to correct short-sightedness. Short-sightedness is a defect that makes a person to view objects which are near and cannot view so clearly objects which are far away from him or her. Are we there? So short-sightedness can also be called myopia. Are we together? Why do we use concave lenses? We use concave lenses because they are able to diverge. They are able to spread out the light rays which fall on them. Number two, we want to look at the bright light. So concave lenses are used in lasers. We talked about lasers to produce or to spread out bright light, because we are able to view things because of the brightness of the light that we have around us. Number three, concave lenses can also be used in flashlights to produce a diverging beam. Children, do you have any other uses? Please attach these uses to the devices that use concave lenses. Are we there, children? Let me hope you've learned. Do you have questions to ask? Please ask the questions so that the teacher will be in position to answer them and to clear out the doubt that you have in your brain. Are we there, children? Thank you so much. This comes to the end of our lesson. May God bless you.